All right, Stats. So we're looking at the 2.7 notes here, assessing a regression model. So, we've talked about how we create this least squares regression line, but now the question is, how well does it fit our data? And that's what we're going to talk about today. So, when we have a least squares regression line, there are really two questions to ask yourselves. Number one, should we stick with the line, or is the best model potentially a curve or a nonlinear model, right? And then number two, if it is in fact linear, how well does it do at predicting? So today's discussion, to talk about whether we should do a line or a curve, we're going to look at what are called residual plots. So we've talked about residuals. So now let's talk about residual plots. And then to tell how well it does predicting, we're going to look at two things. This letter S, which is going to be the standard deviation of our residuals, and this R squared, which is going to be the coefficient of determination. And again, we'll talk about what that means later on. Okay, so what is a residual plot? Well, a residual plot is another scatter plot. But this time, it plots the residuals on the vertical axis. So the residual goes on the vertical axis, and the explanatory variable, the x, right, the x, still goes on the horizontal axis. So again, let's recall what our residual is. Our residual is the difference that equals the difference between our actual y values and our predicted y values. So there's still a y value in a sense, right? It still has a y units labeled to it, but now it's going to just be either a positive number going up or a negative number going down, depending on how the actual y value compares to the predicted. All right, and we'll take a look in a second, and you'll see what we're talking about. Okay, so here we have this idea of interpreting a residual plot. So first of all, let me just show you down here. So down here, this right here, this is the scatter plot. Okay, so if you remember, this was the miles driven and price of a car. So this is the data, the dots with the regression line through them. Okay, this over here, this is called a residual plot. Now notice right here, you'll see the word residual. So that'll be there. But notice the units are the same. This should be in thousands of dollars, right? So the units are the same. But notice here we have 0, right? Smack dab in the middle. This is like your line defining your positive residuals from your negative. And you got all the positive numbers up here and the negative ones down here, okay? And again, each of these dots represents the distance from the actual y value and the predicted y value. So let's pick a point to look at. Let's look at this point right here. Do you see this point? So this point has an x value of, say, 43,000. It's this point on the residual plot. Notice that the actual y value of this point is roughly 23,000, right? But if we go up to the predicted y value, it's roughly 32,000. So if you take the actual and you subtract the predicted, that's going to be 23,000 minus 32,000. That's negative 9,000. And notice where this dot is, roughly around negative 8 or negative 9. And that's in thousands. So that is what this graph's doing. In a sense, the y values of these points is the difference between the actual y and the predicted y. Again, so the points are x, comma, y minus y hat. That's what the graph of a residual plot shows. So how can it help us determine if a model is a good fit? Well, we are looking for no pattern. If your residual plot has no pattern, then that means it is an appropriate model. If you are looking for random scatter in your residual plot, okay, that means that you have some points on the line, some points below, some points above. That's a good thing, okay? Now, if there is a pattern on the residual plot, then the model is not appropriate, right? You don't want all your dots to be above this 0 line or all the dots to be below, because if that's the case, then your linear model is not good, okay? So again, you're looking for no pattern or random scatter. Okay, so example 1. Okay to tap on cans? We use the least squares regression line to model the relationship between the amount of soda remaining and the tapping time for cans of vigorously shaken soda. Here is the residual plot for the model. Use the residual plot to determine whether the regression model is appropriate. So again, it says residual right here. So I know this is a residual plot. Now notice in brackets, I put this little note here. If you look at this graph, you might think that, oh, because the dots are all stacked on top of each other around 0, 4, 8, and 12, you might think that's a pattern. That is not a pattern. If you remember the initial experiment, the explanatory variable could only take on fixed values of 0, 4, 8, and 12. That was the part of the experiment. They took cans and tapped them for 0 seconds, 4 seconds, 8 seconds, or 12 seconds. So that's why all the dots are there. So the question is there a pattern in where these dots are? Well, I have some dots above, some dots below, some dots on. Above, below. So I would say that there's no pattern in how these dots are on this residual plot. So I'm going to say the following. I'm going to say because there is no pattern in the residual plot, the least squares regression line is an appropriate model. For relating the amount of soda remaining remaining, and that was in milliliters, to tapping time, which is in seconds. So notice I'm referring to my response and explanatory variables. In the end, again, I always like to keep things in context. Okay, so because there is no pattern in the residual plot, the least squares regression line is an appropriate model for relating the amount of soda remaining, milliliters, to tapping time. And again, they told us that they use the least squares regression line to model right here. So that's why I knew to include those words right there. Okay. All right, this is objective 1. Objective 2 is coming.